So, hi everyone. I think I'm audible.
Yes, yes, you are
Yeah.
audible.
Yeah. So, welcome all to the very next session that is related to the convolutional neural networks. And since we have seen, ma'am had told us many concepts that are related to the CNNs and how to create CNNs and what are their use and how we can implement them for classification problems. So today we are going to make a CNN, a very small CNN of 4 or 5 layers, and then we'll be doing classification on a data set that is produced by Intel with analytics vidya and launched a competition on that, and then we will use that data set. After that we will after we'll make the model in Keras, then we'll be training that model on the same data set, and then after that we will be testing the model. Then we'll find out that what our model is training right now, so what it is learning right now. So we'll use some character library for plotting the activation. So this is the outline of today's lab session. So I welcome you all. Let us get started with this thing. So I'll request everyone to go to this folder that is already shared with you, and in that folder that you are using every day, in that folder I've created a folder that is day 7 lab session. So I think this is day 7. If I'm wrong, then please make me correct. So this is day 7 lab session. In this day 7 there is a zipped file. So I've already uploaded the zipped file, but we'll see what is the Intel dataset. Okay. So I'll ask everyone to open a new tab and then search in the Kaggle, or just write in the Google Kaggle and Intel dataset. So this is what I was asking you to go for that. Yeah. So this is the dataset that is produced by the Intel. So this dataset contains 6 classes. That is from 0 to the labels is the label is buildings, forest, glacier, mountain, sea, and street. So from 0 to 5, they have given the labels. So there are 6 categories. Okay. Each image in this data set is 150 cross 150 pixels. So it is a square image and it is of 150 cross 150 pixels. And they have given us 25,000 images, but we will be using a limited images because we are having some limitations, like we are not having that much time to train our model, and secondly we are not having that much GPU. So it will train, our model will train, but it will train very slowly on this 25,000 image data set. So I have taken out this data set. I've downloaded this data set, and then I've taken out only the there are three kinds of folders. So they have given us training data set, validation set, and test data set separately. So there are 3 folders: training, testing, and validation. By Intel, there are 3 folders, but we in this session we will be using the validation data set only. We will consider that the validation folder as the complete data set, and then we will divide that data set into three things, like training, validation, and testing. So is it clear for you all what I've said right now? So please let me know in the chat. Okay, then we'll proceed. So I think it must be clear to you. So please write in the chat if it is clear. Okay. Yeah, thanks. So now I'll ask everyone to open a new notebook in your drive. So in my drive, this is my drive. This is my drive. Okay, host muted everyone. Yeah, so I was muted. Okay. So first thing is, what you have to do is make a new collaboratory file. So this is new collaboratory notebook. that we will be using to create our code. So this is the notebook that has been opened, and I'll rename it as CNN classification, CNN for image classification, okay, of Intel dataset. Yeah. So you don't. I am just asking you to see this folder that is already shared with you. That is a Asia Connect. That is already shared with you. So using Collaboratory, we will directly use this zipped file that is already shared with you. So you need not download this file at your end. So please wait and watch and do this with me, and then you will be able to copy this data set in your directory. Okay. So please do all these things with me. Please let me know. Meanwhile, if you are lagging behind, please let me know, or please message me. Wait, kind of thing, so that I'll wait for you. Okay. So all these things should be synchronous. Okay. So I've opened a new notebook. So there are two things. Okay, one is dataset, this dataset, and another thing is this new notebook. This dataset is already shared with you with this folder AI/ML that has already been utilized by you all, and then this is the new notebook that I have created right now. Okay, so can we start? So you can write in the chat start. So we'll
Hello,
proceed
sir.
further.
Hello,
Yeah.
sir. Can you please
Yeah.
tell us how you have opened this collab? This is once again.
Okay, so what you have to do is you should be in your drive. So
Yes,
first
sir.
thing is that just open your drive.
Yes, sir.
Yeah, so just open your drive. You have to press on this new button at the left pane. Okay, so you have to press this. So there is no option for Google Colab here, but there is one more option, that is more. So you have to click on this more. So there are options like Google Collaboratory. Is it fine?
You don't have permission to open something that message is coming in.
Okay, so you have to connect. You just click on this connect to these apps. Okay. Have you opened the collab book earlier in these last?
I did, sir.
You did, but
Not
okay,
during this time.
okay. Do one thing. Is there any notebook? Like, suppose there is any notebook here. Suppose there is a notebook here. Then open this notebook already. That is already with you. Any notebook.
Okay, sir.
Okay. Open that. Open this notebook that is already with you.
Okay,
then
sir.
then use this file, new notebook. Open any notebook that is with you in your
Okay,
drive,
sir.
and then
Okay, sir.
use this way. Like, you can create this in this way.
I can directly go to collab research Google
Sir.
that way also.
Sir,
Okay,
I
you
think
can
I was
also do.
trying to
Yeah.
create the file in shared folder, so that's why it is saying that.
Okay, he's creating. Okay, in the shared.
Creating in the Asia Connect folder, so that's why the permission is not.
Oh,
Yes.
I see. Thanks, Purnima. Thanks. Yeah, that is the problem. Okay, so she is saying that, Purnima is saying that don't use shared with me directly. You should be in this, like, shared with me. Please go to my drive.
Yes,
My
sir.
drive. Yeah, and then you can open, then press new and more, and then you
I have
can open.
opened untitled. I have opened untitled one. Yes.
Yeah, good. Yeah,
Thank you. Thank you.
yeah. So I think I am. Everything is clear with you all.
Yes, sir.
Which link?
Sir, I will share.
Okay. Yeah, thanks, Purnima. So now let's start with this. So we have a file that is a zipped file. That this file contains the data set. So what we will do, we will use a code for that. We will copy this file. We will extract all the contents of this file to some to some folder in your Google Drive. So first thing is that go to my drive. I will ask everyone to go to my drive first. My drive. So this is my drive. Okay. And here I have created a folder. So you can create a new folder, like new folder AI/ML Asia Connect, and then you can write it like day 7. So in this way I have created a new folder. Yeah. So a new folder is connected. Okay. Created. What you have to do is you have to go to that folder. So I have to search AI/ML Asia Connect. Day 7. So this is the folder that I have created. Now I am inside this folder. Okay. What you have to do is, since the file, this file, what is inside shared with me. Again, I have to open. Yeah. So AI/ML Asia Connect is there now. So
Previously, it was there like before
yeah.
searching. He shared with me fourth or fifth file.
Which one? No, Purnima, I need that folder actually.
So earlier it was there, like before searching AI/ML and shared with
Okay,
me.
okay. Yeah, this one. Yeah, thanks, Purnima. So this is the folder. Now what you have to do, right click on this. Right click on this. Everyone go to the shared with me. What we have done, don't get confused. Okay. So clear all the things in your mind. Okay. First thing is that I have created a folder in my drive. In this my drive, I have created a folder for day 7. So create a folder that is day 7 lab session. Okay. So I have created a new folder in my drive, not the shared drive. Okay. So AI/ML, this AI/ML Asia Connect. This I have made from my side. Sometimes it creates confusion. So this is what I have created in my drive. Okay. What I have to do? Go to the shared with me file, that directory, this Google Drive. Go to this AI/ML 10 March 10 2023. Go inside day 7. So what you have to do, shared with me, then AI/ML, then day 7. So there are two things. One is the shared file. Another thing is empty directory. So this is yours. This is what is shared with all. Now what you have to do is right click on that and then add shortcut. Add shortcut. So you have to do this thing, add shortcut. It will ask you where you have to create the shortcut. So I have to create my drive, then AI/ML Asia Connect day 7, and then add shortcut. This I have done. Only I have created a shortcut. Just do this. So when you will refresh this, see, this was an empty folder that I have created, but because I have created a shortcut from this place, a new shortcut has been created here. So please do this and please let me know in the chat. So you can write shortcut created or just write shortcut. Okay. then we will proceed for further. Okay, so many of you have done this thing. So right now, what we have done, we have created a new folder in our drive, our own drive. We have created a shortcut in that folder from the shared file that I've already shared with you here. Okay. Now, no need to go to this shared with me. So I'm closing this tab. Okay. So that there is no confusion. So I have closed this. Now I have a notebook and a folder that is my folder. It is not shared with you. This is my folder. Okay, that can be yours also. So you can also rename it like Samir. I would have renamed it as Samir Asia Connect. No, nothing. Just create a shortcut. Don't do we will do the extraction later on. Okay, so don't try to do any other things. Okay, so this is my folder. Okay, now I'm now creating a new folder inside this, okay, and writing it like data folder. So there is a new folder. So there is a shortcut as well as a new folder that is empty folder, data folder. Okay. Now what we will do, we will extract the files from here to this folder. From here to this folder. Okay. How we will do that? So let's go to the collaboratory notebook. So you have to create a new folder that is data. So just write data in the chat if you have created a data folder. So by logging, by you know, by you know, by replying in the chat, by it makes a log, and then through that log we can track that how much we have, how many steps we have done. Okay. So yeah, thanks. So you have created a new data folder. Now I'm going back to this coding notebook. Okay. So welcome to this collaboratory notebook, and then now we will do some unzipping kind of thing. So import, just write import, and before that, please try to connect it. So please go to runtime. I will ask everyone to go to runtime. Runtime. Change runtime type. So please click on this change runtime type. Click on this none. Go to GPU, okay, and then save it. So what you have to do? Runtime, change runtime type, select GPU, save. Runtime, change runtime type, GPU, save. Now try to connect it. So I'm pressing connect, this connect button. So I think everyone is with me, and then you are here with me with GPU. So you can type in the chat like this with GPU. With GPU. So with GPU is I'm connected with GPU. Yeah, good. So yeah. So I'm having a notebook that has some computation capability added with a GPU by Google. So you can see over here that yeah. So this is what, how much RAM you have got, how much GPU RAM you have got, and then the disk space. Okay. So these are the resources. Now, so first thing is that we have to import. Now, when suppose you are in this notebook and you are not having Google Drive mounted in your notebook, so you have to click on this folder. Okay, click on this folder. Just mount this drive. Yeah, connect to Google Drive. Yeah. So I think my drive is mounted, and here you can see the drive option over here. Yeah, my drive is there. So it shows that my drive is now available, and the folder that I've created is this folder, AI&ML Asia Connect. And when I'll go inside this folder, I'll get one data folder which is now empty, right now empty, and there is one zipped file. So here you can see there is a zipped file, .zip, this file, whose shortcut we have created. So I'm here. Okay. Now, first thing is you have to import zip file. So zip file is the library that we have to import, and then press this play button. Okay. Now, what you have to do is you have to you have to take the two paths like source. So source, I'll write zip so that there is no confusion. So we need to give the path of file from here, and the file should be a zipped file path. Okay. So how to get the zipped file? Here. So here, copy path, and then do this thing. Source and destination. So destination will be equals to single inverted comma, and inside this data. Okay, so I'll copy this path, and I want that all things should be inside this data folder. Got it? Now click on this play button, and then we need another line of another cell for code. So with you have to write this with zip file dot. Now this is zip file. So zip file is this thing, and then you have to call this object. So zip capital Z zip file. It would have given us zip file. This zip file. Second option, zip file. Now we have to pass here what is the source. So source zip comma in read mode we have to R mode. Okay. So in read mode we have to open it as zip. And then we have to call zip dot extract all. So we have to extract all the contents to the destination. So to the destination, this destination. This is a very small code. Okay. So we don't need any suggestion right now. So I'll click on that, and let's see if it happens or not. So I think the data folder will be populated with the extracted files, and we will be having a data set in our own drive. So earlier the data set was a zipped file in this shared folder. Now there is a data inside the data folder that is not shared with anyone. It is your personal folder. So let us click on that. Yes, and there is a Intel data set. There is one Intel data set. Okay. So yes, so there are buildings. So this data set contains images of buildings, images of forest, images of glacier, mountain, sea, and street. So there are many images related to buildings. So they are given a single same category. So building images, forest images, glacier images, mountain images, sea images, and street images. I think extraction is done. So you can type. Okay, so let me copy this code. Yeah. So because I'm not sharing this code because this is for my drive, so it may create a problem for you because it should not be like that. Yeah. Okay, dast is not defined because you have not defined a destination file. Yeah, this way. Okay, so extraction. If extraction is done, uh, everyone in meeting. So type extraction done like this. So we will proceed further. Yeah, thanks everyone. So yeah, good. So it seems like you are with me doing parallel. So yes, so we have done extraction, and when we'll come back to this drive folder, and we'll see that there are two folders, and inside these folders there is a forest, glacier, street, sea, buildings, and mountain. So let us try to print one of the images from these folders. Okay. So what we will do, import matplotlib dot py plot as plt. So we'll do this. We'll import this pyplot matplotlib dot py plot as plt. So yeah, so where the data set is available? Data set is available here in your folder because you have extracted this. Original data set is at this Kaggle platform, and then from there we have taken only the validation data set, and that validation data set is considered. This is the validation folder that we have considered as whole data set. Now we will be dividing this data set into validation, train, and testing, and we'll be doing coding as such. Yeah. So this is let us print one image. Okay. So let us see what does an image inside building class looks like. So these are there are number of images. So we'll copy the path of this image. Copy. So I have gone into the Intel and then buildings, and inside buildings I have gone through this to the very first image, and I've copied the path. So img underscore path is actually this. Now I'll read this image. So img equals to plt dot im read, and I'm reading this image. So img underscore path, and oh, plt dot im read and img underscore path. This is what we have to do. Okay, it gives me suggestion kind of things. Yeah, and plt dot im show this img. So let us see what is an image inside buildings. Yeah, so this is an image for buildings, that is 20057. So this is the image that we have read, and then we have printed the. Yeah, yeah. So yeah, for every session, if it is, if you are doing something on images and you want to see what kind of image is there, so pyplot is very important for that. Oh, and also you can use CV2. So right now I'm very comfortable with pyplot. I don't use CV2 many times because there is some problem with BGR and RGB. So there is some, you have to take care of that. Yeah. So let us do one thing. Since this data set is very big, I'm coming back to this data set. So let us try to remove this. Like we will consider forest. I am removing glacier from here. So I am removing glacier from here. Glacier is gone. Let us take street. Let us also remove the street and mountain. So we'll take three classes. So I have removed all these three classes. Okay, so that to read images multiple times, so you have to plot these images using pyplot. So if you want, there are two things. One thing is reading the image, and one thing is plotting the image. So if you want to read many images, I'll let you know in the later session. If you want to plot many images, you have to create a new code for plotting the multiple images. So and that is a different thing. So right now we don't need it because it takes time and we have to do many things. So there are three folders right now here: forest, sea, and buildings. So I'll come back here and again refresh this So I've refreshed this thing, and let us see in the Intel dataset. So yeah, Intel. Yeah, I'll copy this code. So this is what, and but make sure that you are using your path. Like if the path is different, oh sorry, I have to send it to everyone. Yeah, sorry. So let us see whether this Intel. Oh, so let us. So Intel data. There are three folders. Okay. Why it is showing, I don't know. Okay, we'll see it later on. So it has to, this Google Drive has to, like, it will refresh it, and then we'll come to know that, yeah, three folders are removed and there are only three folders left: forest, sea, and buildings. Now the problem is, sir, give right click. Okay, so in this thing it is working. Here if I am refreshing, I don't know why it is not working. So yeah, now it is working. Yeah. So there are three folders. So it is done. Three folders. Everyone, you are at three folders. Yeah, good. So we are having in our data set only three folders. Now what we will do, we will divide the data set. So the data set will be divided into three not categories, subfolders, three subfolders, one for training, another for validation, and the last one for testing. ठीक है? So what we will do is we will use split folders. Okay, so there is a function known as split folders. So pip install split folders. Pip install split folders. First you have to install split folders. Okay, now create a new folder. Create a new folder that is, I'll write splitted data. So here there is data in which there is Intel data, and now we are having splitted data. Okay, there is some latency. Splitted data. Okay, now what you can do here, we will split this folder, this data folder. Sorry, not data folder, but inside this data folder there is Intel dataset folder. So I'll take this Intel dataset folder. Okay, and then I'll split this folder into three folders, like training. In training there will be three folders: building, forest, sea. Then in testing, three folders, and validation, three folders. So because there are three categories, so we have to keep these three categories into every subfolder: one for training, one for testing, and one for validation. Okay, how we can do that? So I'll use this code, that is, you have to define input folder for that, just like here we have done. So there is a source and destination, so we'll write input folder. So we'll give path of the input folder, that is Intel dataset. So I'll copy this path. This is input folder. Okay. Now output folder. And output folder will be splitted data folder. Okay. So I'll copy path. This. Okay. So there are two folders from where we will take the input, and output folder where we are doing splitting, and then we are placing these subfolders. Now we have to import what we have installed right now. So import this split folders, this import split folders, because this package right now we have installed, and then we have to use split folders dot ratio method. We will be using ratio in the ratio of what? So how we are dividing the data? So how we are dividing the data is 80%, 80% for training, 80% for training, 10% for validation, and 10% for testing. So we will be dividing this data. So first we have to give the input folder from where the data has to be taken. So input folder, then output will be, output folder, and then third thing is we have to define the ratio. So ratio will be equals to 0.8 for what? Training, 0.1 for validation, and 0.1 for testing. So you can write 0.8 or 0.8, and then seed value, like a random variable. So randomly we have to split the data set. So seed is 1008. I take, or take some, some prime number. I'll take 131, 1311, or something which is not divisible, or it will be good. So yeah, so let us split this. So split folders. Okay, sorry. It while yeah. So while while importing, we don't have to give the hyphen. Yeah. So you can see that there are how many files? 1376 files, which have been taken and distributed, divided among three folders, subfolders: training, testing, and validation. Let us see inside the splitted data. So we have got a train where there are three categories. Testing we have three categories, and validation we have three categories. So seed is a random. There is a random number generator that needs a seed through which it generates the random numbers. Okay. So for generation of you, when you'll come, you'll like see Python libraries where we have to generate random numbers. There is a need of seed. So the seed helps in generating a random numbers for a particular distribution. So you can consider it as a seed for a particular distribution. So here, I think you have splitted the folders. So you can type split in and let me know that you have splitted the data set. Okay, thank you so much. So split done. I'm waiting for the other people to
Sir,
do this task. Yeah.
Sorry for the interruption. Sir,
No.
can you please increase the font size?
Yeah.
Thank you, sir.
Is it visible, Purnima?
Sir, you please click the gear icon on the right of the cell, sir, for changing the font size.
Okay, yeah.
Gear icon at the right of cell.
No, this is the page layout. Theme is no. Editor, font size 28. Save. No, this is too much. Okay, so I'll go to a lower font size. So I'll go to, it is 2818, I think. Yeah. Thank you, ma'am. So thank you so much, ma'am. Yeah.
Thank you.
Yeah. So now we have done splitting. Now our data set is ready. So these many steps have been taken by us to create our data set right now. So data set is now ready. So data set is ready. So all set with the data set. So we'll write all set with the data set. Now, we'll start coding with Python. Okay. So for creating a neural network. So for creating CNN, we will be using Keras library. Okay. So Keras is actually given by TensorFlow. So TensorFlow is the parent, parent directory or parent package that gives you Keras. So we will first type import TensorFlow as TF. Okay. Or we can directly type from TensorFlow import Keras. And yeah, so you can do these two things. So you have to import these two, import TensorFlow as TF, and from TensorFlow import Keras. Now, since our CNN contains many layers, okay, so you have to add one by one each and every layer to create your model. So the Keras will help you in giving you some layers which are already defined, and you can add these layers to your model. So import split folders. Just type like this: import split folders. So hyphen. Remove hyphen. Import split folders. Yeah. So yeah, I'm coming back. So in between there comes some certain questions in the chat. So I have to move to that part. Yeah. So we were at this Keras, and then now Keras from from Keras import layers. Okay, so we will be using these layers. From these layers, we will be importing like layers.count2d, layers dot dense, batch normalization, all that, max pooling. So first thing is that we have to create a model. So for creation of model, there are a number of like approaches. So first approach can be sequential model, and the another one is functional API. So functional API. So we can use either sequential or functional. Today I'm giving you the taste of the sequential API. Tomorrow we will be doing certain certain tasks for creation of like segmentation models using functional API. So we'll start with sequential API. So what you have to do, model equals to Keras dot sequential. S should be capital. So sequential. Yeah, sequential. Keras dot sequential. Then you have to create this parenthesis and the square brackets. These square brackets. Okay. So Keras dot sequential, parenthesis, and then square brackets. Now, so we already know that this these images are actually 150 cross 150 as already given by the Kaggle, that the all images are 150 cross 150, and all these images are RGB images. So there are 3 channels in these images. We can also do this by checking this image img. So img dot shape. img.shape is 150 cross 150 cross 3. So let me give you the code. There is some problem with, yeah, so let me give you this code and do, please perform. Yeah. Okay. So Keras dot sequential. Now, just come back, go back to this. So there are images of size 150 cross 150 cross 3. So we have printed the shape of this image that we have already taken out. That is a building image. So it has 3 channels. Okay. So we have to define the input of this image. How we can do that? There are two approaches. First one, we will write like this: layers dot, we know that first one is convolution, convolution layer. So con, and then when you'll write con, then it will give you many options. So I'll take this one, con 2D, this 2D option, con 2D. Now in con 2D, you have to define the filters, number of filters. So filters equals to how many filters we are taking. I'm taking 64 filters in the first layer. Okay. So there are how many filters? 64 filters. So as ma'am has told you that 3 cross 3 kernels are there. So those kernels are here filters. Okay. And we can define the size of that kernel. So I'm defining the size. So kernel size equals to, it is 3 cross 3. So 3 cross 3. You can define like 5 cross 5 or 7 cross 7. So we generally take a square kernel. So the length and width of kernel is same. Okay. Now padding. So I am not taking any zero padding right now. So padding equals to valid. Since the building is in between, the object is in between, like there are cases when the images has very important things on the corners of that image. So if we want to, we don't want to lose the corners or corner information or edge information, then we can use padding equals to same. So I'm right now using padding equals to valid. So valid, padding equals to valid. Valid means we are not adding any zero padding. Okay. Now we'll come to strides. So strides equals to, so we'll take stride of 1. Okay. So 1 cross 1. And now, so since this is the very first convolution layer, it needs some input. So with this convolution layer, we'll give input. So input shape to this con 2D is actually 150 cross 150 3. Okay, this is 150 cross 150 cross 3, and I'm adding comma. So don't forget to add comma after this. So I'm giving you this code. Okay, so line by line we will be adding this. So you can type, if you are here with me, so you can type first layer, first layer done. Oh, thank you so much, Deepthi. Rohan, thank you so much. Akhilesh, everyone, thank you so much. Oh, Mamta, Shyam ji, Satyanarayan ji. Oh, he said, sir, ratio error. Ratio error is there. It means there is something with this. So I'm copying this code again, and to everyone I'm passing this. Okay. Okay. Now we'll proceed. So we can have a convolution layer. After every convolution layer, we generally use batch normalization. So batch normalization is generally used to make our model not getting overfitted. Overfitting means suppose you are having a good training in your model, but your model is not performing on the validation or testing data set. So this is known as overfitting. Like on certain examples, your model have learned many things, but for the other examples, what has to be learned, it has not learned. So to make our model like insensitive to overfitting and all that, so we have to add some normalization thing, some kind of thing. So for adding regularization kind of thing. So for that we can add batch normalization. So I am writing layers dot B capital for the batch. So batch normalization. Batch normalization, and there is no parameter for batch normalization. So I'm adding batch normalization. So it will take, it will normalize that batch with by taking a maximum value and then averaging and all that. So it will do like that. Now, now we'll be having an activation function. Like activation functions will help you to convert a non-linear to linear relationship. Like we have to convert this relationship between the computed outcomes. So what we have to do is layers dot activation, and then we will be using ReLU activation, rectified linear unit, ReLU activation. So I'll tell you what is the graph of. So ReLU activation graph. So because we don't have time, so I'm telling you. So this is the graph for the ReLU activation. That whatever comes that is less than zero, it should be zero, and then whatever comes greater than zero, it should be linearly given. Like this is the ReLU activation. So you can learn this. It is a very easy thing. ReLU activation. Okay. Now we will be having a max pooling layer. So I'm writing layers dot max pooling. Oh, max pool. So max pool, this is 2D max pooling. So yes, and then I have to give the kernel size. So it is 2 cross 2 max pooling, so that it will convert it into, and we'll take stride of 2 cross 2. So it will convert the input with half of the size. So it will give you half sized output, okay, for the input. Now this is the very first layer of that convolution network that consists of 4 layers, okay. So convolution layer, batch normalization, activation, and max pooling, okay. So what we will do, we will copy this. I'm giving you in the chat. So max pool, so it depends on us. Like if you are doing so much max pooling, then all information will be lost. So don't add as many max pool layers. Like if you are comfortable, like because each and every time if you are adding max pooling to the model, the input gets the resolution gets lower and the information is lost. Okay, so to make your model like learn many things up to that resolution, like not less than 7 cross 7 or not less than 14 cross 14, then according to that you have to apply max pooling. Suppose you are applying max pooling and then at the last there is only 10 cross 10 image or 4 cross 4 image. Okay. So ReLU is a good activation function. Softmax we will be doing because softmax we will be using for classification, at the last. Right now we are not doing classification. We are just applying ReLU for non-linear to linear, linear to non-linear relationship like that. Okay, so I'll tell you what is batch normalization. I'll tell you after we will train this model. I'll let you know each and everything. Okay, so let us first, because meanwhile we have to train the model, and that training we'll be having some good time to speak about. So I'll explain later on. So first thing is that you have to copy this thing, and now we are defining second layer. So in the second layer, input shape is what? It is coming from the earlier layer. So I am removing this input shape. Okay. Now we can have less number of filters. So I am writing only 32 filters, and kernel size 3 cross 3. It is good. Now this is the second layer, and we'll make one more layer. So 3 convolution layers. Okay. So 3 convolution layers. And here I'll take it as 16. Okay, so in the first convolution layer there are 64 filters, in the second convolution 32, and then third 16. So I've divided it by 2 power of 2. So yeah, so and each and every time I'm adding batch normalization, activation, and max pooling. So what happens, this is what these have extracted features. Okay, so these layers have learned something by learning the filters, and they have extracted something. And now suppose let us do one thing. This is not complete model, but let us run this cell. Okay, and now we will do model dot summary. So see here, earlier it has taken like 148 cross 148 because we have not used padding and all that. So it has 148, and then that after max pooling it became 74, and then after max pooling 36, and now 17. So now the image became from 148, it became 17 cross 17 image. So this is not an image, it is something that our network, our convolution network has learned something. Okay, and it may be possible that you are not able to, your cognitive system, your brain is not able to understand that image, but this CNN understands it. Now what we will do, we will flatten this. We will flatten this and then apply the ANN for that. So it has what? It has taken out some important features, and now the important features is in the form of an image of 17 cross 17. Sorry, 16 images of 17 cross 17. So earlier there was this 148, 148, 64, and now it is 17, 17, and 16. Only 16 filters are there with size 17 cross 17. Okay, features actually. Now here we will add a flatten layer. Okay, so layers dot flatten, because using this convolution output we will not be able to understand. So by applying dense layers, we will be having a pixel relationship, like one pixel is related to every other pixel. So it will be, there is some pattern that will be craft that will be taken out, fetched out by this ANN that we are going to apply after this. So model layers dot flatten, and whatever Purnima has told you earlier, now that starts with this after flattening. Okay, so now what is the output? 17 cross 17 is now flattened. So calculator will open, and then we'll see. Yes, so 17 cross 17 is now 17 cross 17 is now equals to 289. So there will be 289 neurons. Okay, after this flattening, again we will run this and check it out in the summary. Okay, so layers dot flatten. Okay, flatten F should be capital, I think. So I'll make it capital F. Okay, and now we will see the summary. So summary says after flattening, okay, so 17 cross 17 cross 16 we have forgotten. So calculator 17 cross 17 cross 16. So 17 cross 17 cross 16, it will give you 4624. That is here. Okay, so there will be 4624. Now the feature length will be 4624. Now what we will do after flattening, we will apply some dense layers. So layers dot dense. Now the input is flattened, and then we are applying dense layers. So dense, we are taking 32 neurons first, and then we can add batch normalization also here. So layers dot batch normalization, and then we'll add activation function. So layers dot activation. Actually, activation function depends on your choice, like if your model is performing good or not. So when you will come across, like when you will read a book related to these, CNNs, there is you have been told that there is some back propagation going on. Okay, so during back propagation, your weights are learned actually. So gradients are computed. For learning the weights, gradients are computed. And what are gradients? So gradient is something that is how much different your output is from input. So for that, a gradient is computed. So sometimes it happens that gradient becomes, negative or something. So negative gradients are of no use. So scientists have came out that negative values should be made zero, and whatever positive values are there, that should be left as it is. So in ReLU function, negative values are zero, and positive values are taken as the same. And suppose we are taking ReLU 6. So it is saying that ReLU 6 says that negative is 0, but anything greater than 6 will be 6. Okay, so there will be range from 0 to 6. Okay, so this kind of functions that people have made, and they've tried and tested in their neural net, their CNNs, and they have tested the performance, and they have come out that this thing works very well. Now parameters I have to take. I'll tell you later if time suggests. Then I'll give you how the parameters are computed. Okay. So feature vector is same as number of neurons. Yeah, feature vector. The size of feature vector will be same as number of neurons. Yeah. Now, so activation layers dot activation, and this is ReLU. So ReLU. Again, I'll add some dense layers. So one more dense layer. Okay, so there will be two dense layers. So 16. Now the final one is the classification layer. So for that, what I will do, how many classes are there? Can you tell me in the chat that how many classes are there in this case, in this data set? How many classes are there? There are three classes. Yeah. So Chitra, yeah, Rohan, Deepti, Gori, Mamtaji. Okay, so there are three classes. Okay. Now, because we have taken three classes, so the last dense layer should have three neurons. If you memorize about that image that ma'am in the last session have given you, like where there were cats, dogs, and birds, and one more category was there. So there were four categories. So there will be four neurons. If there would have been, like, suppose we would have taken a whole this Intel dataset, there were six classes. So we have to take six neurons over here. Right now there are only three classes, so we have taken three neurons. And after that, activation should be now softmax. So there comes softmax. So softmax gives you the probability that how much, suppose suppose let me tell you. So there is an image, like let us take like airplane and bird fused image. Okay, so yeah, suppose we will take this image. Okay, so yeah, we are taking this image. So copy image and done. So this image, our neural network, since it has been trained, suppose in three classes like airplane, bird, and dog. Okay, so there are since there are three classes, so softmax will predict how much it is airplane and how much it is not bird or dog. So there is a probability that suppose airplane is 0.7, since this is a probability, so it should not be greater than 1. So it should be less than or equal to 1. So it will give you the output like how much, if it is airplane 0.7, bird is 0.2, and dog is 0.1. So the complete values, if we'll add these values, it will be 1. So sum will be 1, 1.0. So this softmax will give you this probability. However, when we will be using sigmoid as the classification, the last activation function. So in sigmoid, the probabilities are independent. So we would have taken like highest probability, but they are independent. So the airplane has not to bother about bird or dog. How much it is airplane, this is airplane. How much it is bird. So if we are using softmax, then it will how much it is airplane and how much it is not bird. If it is not bird, then airplane will have a higher weightage, and like that it will compute. So we in our in our problems we have taken always this softmax because it doesn't depend, it depends on others, and it will give you a correct output. Sometimes it may happen that sigmoid is giving you same probability for two classes, so there is something. So sigmoid is generally taken when you are having a binary classification problem. Okay, but softmax is something which is taken when you are having a categorical problem, like there are more than two classes. So binary, if it would have been binary classification problem, then we would have taken sigmoid. If there is no binary classification problem, it is a softmax. So since there are three classes, we have taken softmax. So it is clear. Is it clear for you all? Okay, so what does dance layer do? Dance layer is something that is fully connected. If you are there's one thing, Alex Lee Nail. Alex Lee Nail. So I'll take the help of this thing. Okay. So this is actually dense layer. So there are connections between these dense layers. Okay. So dense layer is what? Every neuron is connected to every other neuron. So suppose this is the pixels. Actually, what we have done, we have flattened the images. So whatever filters were coming, like they were coming out to be, I think, yeah, 17 cross 17 cross 16. So when we flattened it up, we have got 4624 amount of pixels. So after flattened layer, there are how many neurons? So there are 4624 here. So there are 4624 neurons over here. Now we have added one more dense layer there that is having like 32 neurons. So these 4624 are connected to these 32 and these 32. So there is some relationship between. We have to find relationship between one neuron to every other neuron. And since we have to do the classification, and classification has only three neurons at the last, at the end. So we have to converge this to up to three. So we have to find the relationship between these. And there may there it may happen in this that these weights, these every line shows some weights. So there can be weights which are having same values, and if they are having same values, so they can be a single. So we can converge this, like we can have lower neurons in the later layers of this CNN, this ANN. Okay, so this is what we have done. So let us plot the summary, and we can see, yes, at the last there are three neurons which will give you the probability values, that is softmax probability values. Okay, so I think this is done from your side. So you have created the model, so you can type model created. I think it has taken too much time today. Yeah, so model created this. Okay, good. So I'm waiting for others to reply if you have created this model, or should I paste this code? So let me paste this code also. So yes, this one. Yeah. So this is the model that we have created. And this is the summary. If you want to see the model, like you can plot the model. using this keras.util. So keras.util dot plot model. This is the function that we can use. So whatever model we have created, so the name of that model is model only. So the name of this model is model. Okay. So we'll use this model, and we can name this whatever image is printed. So we can name that image. So my model, my model.png. So we want to save this like this, and then we can. Sorry, this is keras. I'm very sorry. This is keras, and when then we keras.utils dot plot model. Yeah, so the model is plotted. So we are having what? An input layer. There is a conv2d batch normalization activation, then max pooling. Again, conv2d batch normalization activation and max pooling. So this is what we repeated, and then at the last we are having the activation. Activation is softmax over here. Good. So we have plotted the model. So plotted. So I think you have also plotted this model. I'll show the code. This is the code. Yeah, good. Now, so I'm because we have to, I'm closing this thing. Yeah. Yeah. Now let's start training this model. That is very important to train this model. For that, we have to compile the model. Okay. So for compilation of model, we have to define like what is the optimizer and what are the metrics we are going to use and all that. So we have to compile the model. Now, is there any relationship between model and the data set you have given to this thing? Have you seen like have you seen that there is some can you find any relationship between this model and the data set that we have created? Yes or no? Or there are two independent entities, data set and this model? Just go through your code. So is there any relationship between data set, like this data set, this is split, this folder, like what is the folder, splitted data and then all that? So there is no relationship right now. Yeah. Yeah, in that sense that we have created a model by considering the data set, and we have taken three classes, but right now, yeah, they are independent because we have not connected the model with the data set. So to do that, we have to use like data flow from directory. That is, we'll take the data from directory and then give it to the model. For that, we have to design it. Okay, design the generators, what are known as train generator, data generator, I think. So we have to design the data generators. For that, please code with me like from. This is a pre-processing step. So from keras dot pre-processing dot image import sorry, image data generator. So from keras dot pre-processing dot init import image data generator. Yeah. So it is again. Yeah. Now we will design train data generator. So train data generator is actually image data generator. That will first rescale the input. Now rescaling, why rescale? So I'll show you. Rescale the input to 1 divided by dot 255. So we will convert these images to floating images. Floating point means there are two types of images. So one is the images with values between 0 to 255, and there are images which are floating point from 0 to 1. So any kind of image you can have, like PNG images are always 0 to 1, JPEG images are always 0 to 255. So we have to convert these images to floating point, because our neural network will we will will find out the gradients and then all those things in decimal, like between 0 to 1. So that is why we need to convert these images from 0 to 1. Okay, so we have to rescale these images. Then we can also convert, like, because we can augment the data also. Like, we don't need our model to get overfitted. Like, it should be given buildings that should be straight, like there should be a 90-degree angle between the land on which they are standing. So it is not so, like, always building should be 90-degree, and we have to add, like, we have to change the images so that our this model should be able to identify the images which are very tough. Like, the model should be robust. So for that we will be augmenting our data. So shear range, we'll give shear range. So you can find in the internet what is shear operation. You can turn, like, you can move that image, like you can press, if you will press the image from two diagonal corners, then the image will get a shear. So that is a shear. So 0.2 is the range, and we can have zoom range equals to 0. Suppose I'm zooming to twice. So twice we are zooming. We can have horizontal flip, vertical flip. So there are as many operations that are provided by the Keras to augment the data. So I'll write horizontal flip only. So I'll use horizontal flip equals to true. So we'll have this as a data generator. So yeah, let's see if there is any error. No. So I'll copy this. So this on the fly, like uh, when our images are coming from the folder, so from this pipeline, this image data generator pipeline, they will be randomly converted by applying the these operations, or it will, to some images these operation will not be applied, to some images they will be applied. So it is a random kind of thing that Keras does to augment the data. So yeah. So somebody asked me, sir, can you say what exactly happening when you are giving rescaling? Yeah, rescaling. Yeah. So this image, this is this image that we have taken. Let us see what are the unique values. So np dot unique img. Okay, np we have not taken, so we have to import numpy as np. So see, this image is having how many values from 0 to 255. Every computation in our CNN is between 0 to 1. So whatever weights are initialized, it will be from 0 to 1. Okay. So the input, we also want that it should be between 0 to 1. Okay. Otherwise, if the weights are from 0 to 1, suppose 0.1 is multiplied with 0.1 and 0.2, and in case of 0.1 is multiplied by 244 and 245. So in case of larger values like these values, that weight will have, there is invariance, like there is no variance, like you'll see. But in smaller values, when they are multiplied, there is a higher variance. So in that sense, we will convert the data between 0 to 1, so that whatever our neural network is learning, it will be able to, like, it should have that thing into range of 0 to 1, so that it can I mean, it should be able to learn each pixel more, and it should be invariant, like the higher values will be invariant. So when you'll learn more about this CNNs, and when you'll come to like what, how gradient flow and what are, how they are computed, then you'll come to understand, you'll be understanding this thing, this concept. So since these images are from 0 to 255, every image, whatever is considered in our data set, we have to convert them between 0 to 1. So using this step, train data generator, it can be converted. So we can use this train data generator for validation data and train data. For testing, we don't want to convert this, because for testing, I think testing is the original data that we have taken directly from nature, and directly it is natural. So for that, we don't want to augment the data. So test data gen is it will consider only sorry, equals to image data gen. We will consider only the scaling uh, for that is scaling operation. So I'll use only scaling for test. Okay. So for training, we want to make it robust. For testing, we don't have to augment the data. Okay. So there are two data generators that we have taken. Now we have to these are two things that we have uh, like defined how we can do these two things. Okay. From center, no, shear is having some range. It will be randomly applying through that diagonal and then two edges. It will apply. So I don't remember that mathematical concept right now. I'll let you know when it will come to my mind. I'll tell you. So this is what we have done right now. Now we are generating. Now we have only defined the pipeline. Now we will generate the data. So train generator will be using train data gen dot flow from directory. So flow from directory, flow from directory. Now we have to give the path, that what is the, so we will define over here. Train dir. So train dir is what? Train dir is, we have actually splitted the data. So yeah, so train data directory is this directory that we have splitted. So copy path train directory. So train data directory, I have added a slash at the end. So train directory, and then validation data directory is val underscore dir equals to this, and test dir equals to this. So this is test. So there are three directories: train directory, validation directory, and test directory. So for training, we have to pass train directory. Now we have to define that what is the target size. So it also helps in like upsampling and downsampling the input. Like in some cases, the input is very huge. Like it is having a big resolution image. Satellite data has 2000 cross 2000 pixel images. So we can convert them into a lower dimensional image by applying this Keras image data generator, and then we can resize. So how we can do that? By by specifying the target size. So target size is same. We will take same. So 150 cross 150. By default, it is same. So 150 cross 150. Batch size. So batch size I'll tell you later. So batch size is equals to how much at a time how much it should take. This pipeline should take the images from the folder and process them. So batch size we have taken 8 because this is very limited computing environment that we have right now. And class mode. Class mode is actually, since we are having more than 2 classes, so this is actually categorical. You know, it is not binary since we are having 3 classes. So I'll write categorical. This categorical. Okay. So this is what we have defined a train generator, and a train generator takes data from train directory, and we have defined the target size, batch size, and class mode. Okay. So this is train generator. Yes. So it is saying it has found 1086 images of 3 classes. Same is for validation. So I'll give you the code. So here I'll give you the code. Yeah. So train generator, train detergent dot flow from directory. Now here we are using validation directory. So validation dir. Okay. Here you can see that we have defined train generator and test generator. Train generator is utilized by both validation and training. Test data generator is used separately. So we will define test generator, and in test generator the batch size is 1. So we have to specify the batch size. Batch size equals to 1 because every time we will take 1 image. So batch size is, sorry, not here. This is validation. So here this is test generator. Test generator, test data gen, because we have to use test data gen, flow from directory, and then test dir. Since we have taken same while when we were splitting the data set, we have taken the same value for both validation and testing. It means both the data sets will have same number of images, or there can be, if suppose the count is odd number. So validation may have a greater value, one more image, but not more than that. So so there are 140 images in this, because every folder may have one more image. So in that case, like, it is having this. So 140 images for 3 classes. So it is done. Generator done from your side. You can type in the chat, generator done. Okay, I'll wait. Okay, generator we have to explain. So see, here we have defined, the operations. So here in this train data gen, we have applied some operation. We are going to apply some operations on the fly when we are training the model. So whatever images are coming, and these images are actually converted, like they are rotated or they are sheared. We are applying unaligned forces from, like, we are applying forces from different. If you will apply forces to an object from different angles, then that object will, deform. So this is what shear is actually. So deformation kind of thing. I don't know how they have implemented in Keras, but we can find it out. Now zoom is what we can like we have to zoom inside the image. You already know that it is some kind of interpolation method where we can have a in the depth view of that image, and then we are applying flip operation. Flip is like vertical flip, or we are rotating it 90 degree or 180 degree. So there is one flipping. So these are the four operations, three operations for like changing the spatial spatial information of that image. But rescaling is what we are doing, because the data that we need in our network, that should be between 0 to 1. So making the images floating. So this is what these are the operations that are defined using image data generator. Now this image data generator will be used when we are taking out the images from directory. So this is flow from directory. Flow from directory will give you you are taking out the images and you are applying it on it the train data generator, such that the images are from this directory. The target size that the coming out the results that are the images that are coming out should be 150 cross 150. How many images at a time should be taken? So it is 8, and what is the class mode is categorical. So this is how we are defining the generator: train generator, validation generator, and test generator. Is it okay, Rohan? Okay, so let us now compile the model. So let's compile the model. Now compiling the model. So to compile the model, you have to give some parameters, like you have to define the optimizer first. So optimizer helps you in training the model. Sir, class mode is always categorical. No, not always categorical. In case of binary classification, it is not categorical, it is binary. So when we would be having two classes, it tomorrow I'll tell you we will be using binary, but we will not be using this flow from directory. So binary is in the sense when there are only two classes. So class mode is categorical when there are more than two classes. So categorical here means more than two classes. So let's compile the model. So for compilation of model, we have to define the optimizer. Optimizer will help you to lower the loss in your model, so that model can train in a good direction. So from Keras dot optimizers, we can have many optimizers, but Adam is actually most common and most successful, one of the successful thing. So SGD we can take, RMS crop we can take. So today we will be taking these two optimizers. We will define optimizer equals to, and then we will define certain parameters of Adam. So right now I'm defining learning rate. So learning rate I'm taking it 001, learning rate to be 001, or you can write LE point minus 3, like sorry 1e minus 3, that is 10 to the power minus 3. So in that sense also you can. Now you can type model dot compile, and then we will define optimizer is OPT, that we have already defined above this OPT. Then what we have to define, another thing is loss. So what is the loss? How we have to calculate? So since this is categorical information, so categorical cross entropy, loss, and then what are the metrics? So metrics we can define, like in this case this is very simple. So accuracy is the parameter. AUC we can also define. So AUC, precision recall, sorry, AUC precision, so precision recall, So these are the it is saying optimize the valid cloning distribute. Okay. So optimizer. Yeah. So optimizer is this. So we have compiled the model. So we have decided that the model should be trained with the help of Adam optimizer. It should compute the loss based on this categorical cross entropy function, and the metrics that a model should have is accuracy, AUC, precision, and recall. AUC is actually area under curve, and that curve is ROC curve. So receiver operating characteristic curve. So this is very complicated, but you will learn. You will try, like, at this point of time you need not bother about these things, but later on when you'll try, you'll more be into this cnnns and all that, then you'll be able to learn what are these AUC and all the metrics. So now this the very important thing is, now we will try to fit this model. So history is very important. History, so it will keep on recording that what was the accuracy when it was first epoch, what was the accuracy when it was second epoch. So all that is considered as history. So history equals to model dot fit, and then we will decide, give train generator. Yes, so train generator will give it the training data. How many epochs? So I think epochs equals to 5. 10 will take 10 epochs, since it is 740 right now. So yeah, seven epochs are we have taken. Now batch size. So batch size is we can take 8 as, because very low RAM we are having right now. And then now comes the validate. Here you can see validation steps are the validation data. Yeah, so validation data is validation generator. Validation generator, val generator is the val generator. And then we have to define another thing. Callbacks I have not, so I'll later tell you. So validation batch size, it is giving validation batch size as 8, or we can have 4 as value. So we can have the different batch size for different purpose. Like training, we can have batch size of 8, and validation we can have batch size of 4. So yes. So now let's start training the model. And val generator, it is not taking val generator validation data val generator. Why it is not taking? Hmm. Now it is taken. See here, so you can see the metrics and the validation also. Like on validation data, it is not performing very well, although it is good in this training accuracy. It is not performing good in validation. Now validation has increased. Yeah, so validation precision, validation, yeah, validation loss is 0.64, and training loss is 0.4. Yeah, so we can train. We would have trained it for more epochs. Like suppose I am again considering it for another 20 epochs. So you can train in multiple times. Yeah, so it is done. So we have achieved the accuracy of 0.88.24, 0.8824. Okay, so we can validate. So model dot evaluate we can use. So model dot evaluate. Now for evaluation of model, we can use validation generator. Validation generator. And for batch size, for each image we will calculate. So batch size equals to 1. So the results we can store directly to uh, eval results equals to this. So evaluate. Yeah, so it is saying that loss is 0.3389, accuracy is 0.8824 on validation data, because we have used validation generator, and AUC is 0.97, precision and recall is this. So this is, now we will go for the prediction. The beautiful thing that is behind this is validation, sorry, testing. So we can use prediction like x equals to model dot predict. Now these two data, like training and validation, it has been used during uh, during when you are using, when you are training the model, you are using both validation and training. But right now we are this test data is not seen, it is unseen for the model. So this is the main part, like model should work good for the testing data. In many of the research papers we have seen that the people are comparing their studies by considering the same data set with the same train data set, validation data set and test data set. So that there is no there's no randomness. Like suppose you have taken an easy data set for testing and then your results are becoming better, are coming out to be good. So this is what these days it has happened with the help of GitHub. So they have given the data set, and they have bifurcated it into the train, test and validation, and most of the researchers are following that data set. So model dot predict and test generator and batch size equals to. So we will examine this thing x. What is x? So when we were using evaluate, there this was calculating the metrics, but right now it is not calculating the metrics because it is giving you the output. So what is x? So here you can see that there are many values, like there are 3 values for each input. As I have already told you earlier that for each input it will compute 3 probability values. These are these 3 probability values that are less than 1. Okay, so when you will come across this particular line, you can see that the highest value is 0.95 for class 1, first class. Okay, so you can use this, like we can also print train generator dot class indices. So you can find out that building was 0, forest was 1 and C was 2. So these were the labels that were given to each of these classes. So by examining this x, we can have that at 0 position there is a highest value. So the class indices for the first particular input is having highest value for 0. So it should be what? It should be building. If it would have been second, suppose the second value would have been greater than other two then it would be forest, and then accordingly C. Okay. So let us do one thing. Suppose we are storing the results. So np.arg, this function is very important. np.arg max. This function will compute the highest um, this index, like which index is having highest value. So when we are computing this, so the index 0 is having highest value. So np.arg max will give you 0 for this particular row. For this row first. Now for this row, this value is highest. So it will give you 1. Suppose here this is highest, so 2. Here this is highest, so 1. Here this is highest, so 0. Likewise, this will give you the result. So let us calculate this thing. And another 5 minutes we will take to generate, or let us do one thing. First, we will generate the activation maps. We will see that what our model is right now learning. Okay. So for activation maps, to see that what our model has learned, we can use Carrect. There's a library that is Carrect. K-E-R-A-C-T. Carrect is the library that is used to display the activation function. So you can type Carrect PyPy. So this is the repository where you can find this library. So we can install Carrect. So pip install Carrect. Yeah. So now you can see over here that it is correctly installed. Now we will be using Carrect. So suppose we are taking one image, like let's take one image. The same image we can take, or earlier, or from the test we can take. So buildings we will take. Okay. So let's take from the test this building image. Copy path. So img equals to plt dot imread. This is the image. Now let's do one thing. Let's plot this into plt dot im show img. Yeah. So this is the image. You can see the buildings are behind these trees. Okay. Now let's understand that what our network, if it is given, our network is given this kind of image, what it learns from that image. So with the help of activation functions, we can see what this image is actually, how it is being understood by the R model. Okay. So how we'll do that? We will use Carrect for that. So import Carrect. So first, because our model take input as a batch. Okay. So because we are giving only one image, so we are creating a batch of one. Okay. So img equals to np dot expand dims img comma access equal to 0. So earlier our image was, this image was actually 150 cross 150 cross 3. Now image is actually 1 cross 150 cross 150 cross 3. So this is batch of 1. It has only one image of 150 cross 150 cross 3. Now we will get the activations from Carrect. So Carrect dot get activations. So this image is given to the model that we have trained. So this model and this image. And then we are going to plot the activation. So Carrect dot display activations. Activations. the activations we have got earlier. So these activations we have to display. Character dot display has no to display. Oh, sorry. So here you can see that higher values, the brighter pixels will represent more information as compared to the lighter pixels. So here you can see that wherever there was building, see, there was building, it can find building or another thing like that is not tree, then it is giving you that yellow part, like here there is a building. Okay. So these are the activation, like after convolving these filters. So what are the filters? Filters were we have given filters like in this model when we were creating this model. There were filters like 32 filters, 64 filters. So each filter has um, different view of understanding that image. Okay, so different weights are there. So by multiplying those weights with these images and all that, so we have got this kind of output. Uh, we can get the activations for each layer, like how after batch normalization, how it looks like. So it looks like some blurry, because it has done some kind of, transformation from one domain to another. So this is max pooling. So you can pixels, you can select. Yeah. So these are the activation functions you can see. Now, this was actually how you can see the activations, and by using predict function for every image, you can identify that what is the prediction for that image. So how we can do that? So, ma'am, can I have more time, like 7 or 8 minutes?
No problem, Samir.
Yes, ma'am. Yes, ma'am. So
The
let us
only
do
thing
that.
is that
Try to complete it.
participants, they must be tired. So
Yes, ma'am.
if they agree, we can.
Okay, ma'am,
Yeah.
I'll share the notebook. It is a very simple code. So I'll share a notebook in which this code is available. So if they want to me, then I'll explain them right now.
No. What I'm saying that let us ask participants also.
Okay.
Preeti, if you don't mind, yeah.
Yeah. So, because they were learning with all interest with the messages. It
Extra
was
time is
appearing,
fine,
so I
ma'am,
thought
because
maybe it's
it is
okay.
very interesting, ma'am. Extra time is fine.
Thank you so very much. I mean, we sincerely thank you for your interest in this.
Okay, thank you so much, ma'am. So let's start doing some operation to find to for on prediction. Some prediction is going on. Suppose so you have an image, this image, and your model has predicted something, so it is predicting in the form of a probability for 3 classes, and the highest class will we will consider it as the label for that image. So how we will do that? So let us take one set, like let us take C images. Okay, so we'll take results as a empty list, and file name as a different list. Now, how to read multiple images? That was the question that was asked in the start of the session. So import OS. So with the help of this OS, we will be able to read as many images. So from the path, so path will be this directory. So we'll take C as the directory. Okay. So I'm predicting on the data set, the test data set, which is the C test data set. Okay. So for file name in os.list dir. So this not test, this is path. So path oh sorry path. Now img equals to, I'll tell you, plt dot im read, or let me first print the file name. So this operation, I'm taking out this to a new cell. So we have defined these three things. This is very easy. Now for file name in os.listdir, this os.listdir will help you in identifying the file names. So this path is path for this C folder. So it will print all the file names of this folder. So print file name. Okay. So when you will run this, these are the file names that were here. See 201. So later on we will get 20168, this 20168, 20236. There should be, there it can be somewhere. Now with the help of this file name and the path, we will open the image. So img is equal to plt.imread this path, so path plus file name. So one file will be read when throughout this loop. One file will be read at each loop. Okay, so at each time. So this is the image. Now, since file name we have added, so file name dot append this file names dot append file name. So this file name, whatever file name will be there, it will be added to this empty directory. So it will be populated, and now image equals to, as I have already told you earlier, that we have to convert this image. So this we have to expand. So image equals to np dot expand dimensions. This operation should be applied every time when you are taking only one image. Earlier, when we were using this prediction test generator model.evaluate, we don't have to, there was a batch. Okay, but here there is, since there is only one image, then we have to expand the dimensions. Okay, so model.predict, so we have to get the prediction. So pred equals to model.predict, and then we have to pass this image. Okay, so we have got the prediction and we have got the probability. So how we can get the class label? So class label is equals to np dot arg max. Okay, and then pred. So at whatever index value there will be highest probability, it will return that index value. So results dot append this index value that is inside the class label. So class label. So this we will do. So it is predicting for each and every image. Okay. So it is predicting each and every image. Now we can print these file names and results. So for I in range 0, len file names. So this up to this length it will loop and we will print. So print result. We can print the result with the file name. So we'll use file name first. So file name and then file names I, and what is the result? Label. So class label. So class label, and class label is what is the results? Okay. So results I. So now let us check it out whether we have done the results dot append. Okay, class label, yes. So let us see. Yes, so let us see what was the class label for C. It was 2. So wherever there will be 2, it is correct. But wherever it is like this, for 22107 image, it is false. It is giving you wrong label, like for these two images. So let us, at the last, we will print that image. Why it is giving us the wrong results. So this image is what? 22107.jpg, and we will take this path. So plt.imshow this path plus this file name. Okay, so this will be concatenation. Cannot be converted to float. Okay, so first we have to read that. So plt.im read. Yeah, so wrong spread equals to plt.im read and plt.im show this wrong spread. So let us see what kind of image was that and why it was giving you label. So yes, so here it was C, but it was giving the label of what we have taken 22107 to. So 22107 it is giving label 1. What is label 1? So label 1 is forest. So I think it is considering this as forest, this part. So this is the major part, like so it can be due to this, can be. So this is what in the last day of this whole FDP, there is a topic that is explainable AI. So this is what this is the main concern of today's research problems. So thank you everyone. Thank you so much, ma'am, for giving me more time. Yeah.
No, no problem, Samir. And if the participants are happy, they are doing things, then of course time is not a problem for us. So thank you so much, Samir, for another excellent session. And more important is that you have engaged everyone, that the people are doing things and they are sharing it on the chat. That is the most important thing. So I'm happy that participants are taking interest, and we thank you all. And we understand that today was the busy, hectic day. The first session also spill for 15 minutes. That this next is also. So
Yes, ma'am. There were many things to explain, but the time was not